Hello, chemistry classes. We're going to be doing a couple demonstrations for you today back in the chemistry classroom. Once again, my son Ethan back behind the camera. Say hi, Ethan.
Hello.
Okay, so our first demonstration, one of two today, is going to be dehydration of sugar. So when you think of the word dehydration, you're probably thinking of, losing water. And so this reaction is going to be with sucrose, table sugar, is going to react with sulfuric acid. But you see over on the product side, we have water. We have H2O. And we have elemental carbon and water as the products. We still have a mixture of water and acid as well. But again, when you think of dehydration, we're thinking of like losing water. Well, the sulfuric acid is going to dehydrate, take the water and the carbon away from the sucrose molecule. This reaction is also very exothermic. So if you remember, exothermic means releasing heat, so the surroundings get hotter. And so it's so exothermic that the water actually will be in the form of water vapor. It'll be past its boiling point. And so that energy is released because we have this large covalently bonded molecule, and those bonds are going to be broken. And so when you break bonds, energy is released. So now let's go back and see this demonstration. All right, we're back at the fume hood, and we're going to take our sucrose, or table sugar, and put some in this beaker right here. Pull that off a little bit. So I have some concentrated sulfuric acid that we're going to dump in. Move this out of the way a bit more. So again, the H2SO4, concentrated sulfuric acid. Make sure it's mixed up a little bit here. That sulfuric acid gets mixed down to the bottom parts of the sugar. So this reaction takes a little bit to happen. As you can see, there's a little bit of color change going on here. We'll rotate this a little bit. I can actually mix this maybe a little bit more here. So there is color change going on. Heat's being created. As the reaction continues, the heat will build up. The reaction will take place a little bit quicker. So now we wait just a little bit. There's probably a little bit of bubbles going on. The reaction will really start to take off when we start seeing water vapor appear. The reaction will be so exothermic, and there we start to go. We start seeing the water vapor. There's probably some sulfuric acid vapor as well, so we definitely have the fume hood on as well. So what we're seeing is that carbon kind of being pushed up by that water vapor as well. Some people say it kind of looks like those snakes you buy at 4th of July. They kind of grow. That's not this reaction, but that is carbon. And so we'll kind of see, certainly this is very hot. I certainly wouldn't want to touch that with my bare hands. Continues to grow, and so that carbon is has a fairly low density to it. And so once it kind of stops, I'll kind of break off a piece and kind of show you that it's fairly low density. It seems to be still getting a little bit higher here a little bit. So at a certain point, the sugar runs out, and you're left with just some water and some sulfuric acid. Of course, the carbon as well. Looks like the reaction's slowed down quite a bit. Take this and pull it out a little bit. Again, pretty crumbly, pretty low density. But this is carbon. This is that carbon part of the product. We have water vapor, you can see as well. So put that back down. So I hope you enjoyed this little demonstration. We're going to do one more here. Okay, for our second demonstration, this one's going to be called nitric acid and react with a penny. And our penny, of course, is made of copper. At least the outside is going to have copper in it on our new penny. So we're going to take nitric acid, which is HNO3. It's going to be concentrated nitric acid. It's going to react with the copper. It's going to produce copper nitrate, nitrogen dioxide, and water. Nitrogen dioxide is a gas. It is a major component in like air pollution, or what we call smog. When we do this reaction here in just a bit, this is going to be the brown gas that you can see. This reaction is also very exothermic, so a lot of heat's being released in this reaction. Let's go back and see this reaction.
1.
All right, so here is our penny we're going to use. That's going to be the copper part of the reactant. And so I'm going to drop it in this beaker. And then I have nitric acid in here. And so we're going to dump the nitric acid over the penny and then watch the reaction. We're starting to see a little brown gas. That's that nitrogen dioxide gas. Certainly, we want to have the fume hood on like we do in this reaction. We want to breathe in that gas. Exothermic as well. That would be fairly warm at this point. After the gas sort of settles down, the gas reaction slows. We're going to see, I think, a blue color. And that blue color will be indicative of copper ions. They're going to be present. Interesting, this was a penny that's new enough to where just the outside is covered with copper and also a zinc inside as well. So the reaction is slowing down a little bit. We're getting a little bit less nitrogen dioxide. Starting to see a little bit of maybe blue color, just a little bit in there. Certainly still reacting a little bit. We'll wait just a little bit longer. If I tilt this a little bit, you can see kind of that bluish, greenish color right there. It's starting to react a little bit more, coming in contact a little bit more. All right, a few minutes later, we can see certainly kind of the blue solution. So we know kind of there's copper ions. And here's our penny, which we're basically kind of down to like the zinc disc. It's very, very thin. It may be hard for you to pick that up on camera. The penny certainly has lost quite a bit of mass here. Certainly that elemental copper is now, with copper nitrate, copper with a nitrate as well. So certainly maybe a little bit of copper left. But there is our reaction with copper and nitric acid. Hopefully enjoy these couple demos. Have a good rest of the week.